So in the last lecture we talked about the moment of inertia of a compound object. Let's look at something like what I would call a broken object. Okay, so let's say we have a disk, and the disk is rotating about its center of mass. So we have an axis that's going, coming out of the screen at you, and this is the object. So the disk is rotating around in this direction. Okay. Well, we know that the moment of inertia of this, I, is equal to the mass of the disk squared times the radius of the disk squared over 2, where this is the radius of the disk. Okay. So the reason I would call it what I'm about to talk about a broken object is, let's say that we only have a chunk of this, right? Let's say we just have a wedge like this. Okay, and let's say this wedge is a quarter. So imagine cutting this disk into quarters. Okay, so let's say this is just a quarter of that. So in other words, the mass of this is the mass of the original disk over 4. Okay, well, we see that the moment of inertia of this, because we have 4 of these, so if we have m over 8 r squared, and we call this the moment of inertia of a wedge, we see that the original moment of inertia is just 4 times I wedge, which is m r squared over 2. So by using the fact that if we look at this disk as a compound object made up of 4 smaller objects, this gives us the formula for the moment of inertia of a wedge. But let's look more closely. What if I say that the mass of the wedge is actually m? Then the moment of inertia of the wedge is m r squared over 2. It has the exact same moment of inertia as the complete disk. Now, does this make sense? Well, let's look at this. If I say the new moment of inertia now is 4 times I wedge, then this is equal to 4m times r squared over 2. But again, this makes sense because that means if this had a mass of m, then the 3 missing pieces also had masses of m. So if we add that together, the new mass this mass actually becomes 4m r squared over 2. So in other words, if we divide up an object, as long as we do it symmetrically, then we can get a new moment of inertia, and that will actually have the same moment of inertia as the total object. And so I think this is kind of an interesting twist. It's almost the exact opposite of a compound moment of inertia. We're saying, what happens if we chop a bigger object up into smaller objects? What would be the moment of inertia of a smaller object? And it turns out it's exactly the same as long as we obey the symmetry that we had from the higher level object.